Welcome back to a new machine learning tutorial. In this video, we are going to talk about the ordinary least squares method. We are going to talk about the theory behind that, and we are going to look at the formula. Then we are going to code it using Python. Let's start coding. I will be using VS Code as the code editor in this video. You can prefer any code editor that you want. I will say ordinary least squares, and I will be creating a Jupyter notebook like this. Next up, I'm going to select my kernel 3.11.4 and I will say ordinary least squares, and let's talk about it. So this is a method used in linear regression to estimate the parameters of a linear model. The core idea of ordinary least squares is to minimize the sum of the square differences between the observed values and the predicted values from the model. So we can type like core idea is minimizing the sum of the squared errors. So by this operation, it finds the best fitting line through the data. So let's talk about the math behind that. In linear regression, we can write a formula like target is going to be equal to the intercept beta 0 plus beta 1 x1, and we are going to have beta 2 x2 depending on our x size, and at the end we are going to have something like beta n xn, and we are going to have an error term at the end. So in this linear regression formula, y is the target we have and beta 0 is the intercept, beta 1, beta 2 and beta n is the coefficients we have, and the x's are going to be our input features for the model, and error term here is the difference between the actual and predicted values. So we are going to give x's to our model and we are going to get a predicted value on the y side of the equation. So by the way, I wrote like x1, x2 and xn, but let's say that you have one x feature only. Let's say that you have a problem like you have education values and you are trying to predict the salary, and let's say that for 2 years of education the salary is 30,000, and for 5 years of education 7,000, and for 1 year of education salary is like something like 15,000. In this scenario, you're going to have something like this because you only have one x feature in here, education, and you are going to have a formula like this. So beta 1 is going to be the coefficient that shows how education affects the salary. So this is our formula, and OLS, ordinary least squares, estimates the coefficients beta by minimizing the sum of squared residuals. So we are going to have a residual formula like our residual is going to be equal to the actual y values versus minus predicted ones. We can write like y prediction. So in here we are going to make estimations with this formula, and we are going to take that y prediction values and we are going to compare them with the actual y values for finding the difference. And for minimizing it, we will say our cost function is going to be the sum of the differences between the y true minus y predicted values, and we are going to take squared version of it. Okay, great. We can start coding right now. We are going to start by creating a data to work with. So I will say import numpy as mp, and I'm going to import matplotlib pyplot as plt for visualizing the data we create, and I will say from scikit-learn.datasets import make regression. I'm going to create my data with this. So I will say x and y. X is going to be the value that we are going to be giving for the prediction, and y is going to be the value that we want to predict. So I will say make regression. I will say number of samples, we can say 1000. Number of features, we can say 1. I want it to be a simple one, just like in the example education and salary. And next up, I'm going to add some noise, like I will say noise equals to 3. And I think with running this, we are going to have an x and y, and this is going to be our data. We are going to use these vectors, and I'm going to quickly visualize it like I will say plt.scatter, and I'm going to pass x and y, and I will say plt.show. So this is going to be our line, and we can increase the noise, like we can say 10 instead of 3, and we are going to see that we are going to have not a straight line like this before. Yeah, I think it's better. We can also make 20. Let's do that. And okay, let's work with this data set. Okay, so for creating our model, I will say import statsModels.api as sn. Next up, I will say x with intercept, and I will say statsModels at constant, and I will say x. Next up, I will say ordinary least squares model. It's going to be equal to the statsModels.OLS, and I will say y, and I will give x with intercept next. So we can fit the model like results is going to be, we will use the fit method from statsModels, and we can say results.summary right now. Our model is ready. So let's talk about this. In here, coefficients are the intercept and slope. So we are going to have something like y is going to be equal to the 0.6636 plus 2390 multiplied by x plus error term. We are going to have a formula like this in this model. So we have the r squared value of 0.58, and we can increase this number if we decrease the noise, like let's say 10, and make them all run again. And we are going to have the r squared value of 0.59. We can say noise is going to be 5, and I'm going to make it run again, and we are going to see a much higher r squared in here. It's 0.99 right now. I want to show this because the higher r squared value you have, the closer it to be 1, the better fit you have. So it takes value between 0 and 1, and if you have a better value, like closer to 1, that means that your model is better at predicting the y. And we have the f statistic here, which tests whether at least one of the predictors has a non-zero coefficient, and we have a regression table like this. So we have our model right now, and let's say that we want to make predictions with our model. So the formula is, and I updated the formula in here according to these values for this new data and new model. So let's talk about what we did in this video. We talked about the ordinary least squares, the idea behind that, and we talked about the linear regression formula. I give an example for education and salary, and we talked about the residuals, and I wrote the cost function in here. We are trying to minimize this. Next up, we created a data set, and we created a scatter plot on that, and I showed you how different noise values can affect the data creation. Next up, we imported statsModels, and we add a constant. Then we created our model in here. Next, we trained our model and talked about the results of our model, and we talked about the formula of it. And let's say that you want to make predictions with your model. You can simply say results, the thing that you trained your model on. Let me quickly show you this, the predict, and you can pass, like, let's pass our x with intercept, so you can get predictions like this from the model you trained, and now you have a model that you can make predictions with. Great, let's get to the outro. Thanks for watching this tutorial on ordinary least squares. I'm sharing new data science videos on my channel every week. You can subscribe to my channel for more videos like this. Also, I have a playlist named Machine Learning Tutorials where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Have a great day.